Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 5.4, Convergence, Divergence, and Oscillations. So, convergence, divergence, and oscillations are words that you need to know the meanings of, and you have no need to learn the proofs of whether a series is converging, diverging, or oscillating, but you will have enough information by the end of the question to just say from the get-go, does it converge or does it diverge? And that I'll tell you exactly what those mean. Let's first start with a converging series. So it is a sum to infinite from 1 of 1 over n squared. So the reason that this whole series is converging is because of a certain property. So if you plot the value of the component, let's say the component C against the value of n, you get an exponential decay curve. So what that means is this approaches 0, by the way. So what this actually means is that if you add all of them together at a certain rate, then you should basically add up to a certain point when we get to continually add something too small to be noticed. So the sum of the graph should look something like this. So sum up to n would look more like this. So it approaches a stable value. So this stable value is the limit of the sum, and when a series is converging, it converges to a certain value x. X can be any real numbers. For this course, you're not supposed to know anything to do with complex sums, so I'm not gonna so excuse me. So yeah, basically do not worry about things like that, as it's just too much for you to handle currently. Right, so let's see. So again, we start from 1, so this is 1. So not 0. This is not a standard axis, by the way. So with this, we can look at a diverging series. So divergence is something like this. 1 on n would be a good example. So the reason that this diverges is if you plot the curve, you have, once again, this should be the component. So once again, you get something exponential, except no longer exponential, it's a steady curve. So what this implies is that because the rate of which it decreases is too small, that the sum curve looks more sort of like this, and it doesn't actually curve that much, and so it don't approach a certain value, and it converges towards infinity. So and this one converge towards a certain x. So when a value converges to plus or minus infinity, then you know it is called a diverging series. So with these two sorted, we need to talk about something a bit more complicated. So what if I have this sum to infinite from 1 of sine x? Actually no, that is a really poor example. What if I have minus 1 to the power n? Let's do this. This one is more, this one demonstrates better. So what you would have done here, if you plot the graph or just list the number for now, the first one will be -1, the second one will be 1, -1, 1, -1, etc. When we sum these, depends on whether infinite is odd or even, you will get either -1 or 0 as your sum. Now here comes the problem. Technically it doesn't go to infinity, which means it's not diverging, nor does it converge. Like it doesn't go tend towards a certain value, it oscillates between 2. So this will be an oscillating series, and the solution to these are practically undefined, but depends on what method you use. The sum can be basically any value. It's just number artwork, really. So there was this one question, I'm not sure if it's an internet question or not, says that if you sum 1 plus 2 plus 3 up to infinite, you get -1 on 12. And technically you can do that with any infinite sum, because it exploits a certain issue in our understanding of infinity. So yeah, it technically works, but it doesn't really. So yeah, basically take it with a grain of salt. That's what I want to tell you. But you do not need to know the average values for series, so you just need to know the meaning of convergence, divergence, and oscillations. With that said, this is it for this video, because there ain't a lot to talk about. For this part, you just need to know again the word, the meaning of the word. You do not need to actually prove it, because proving convergence is way too complicated for A-level purposes. It's something that people do at uni, and yeah, it's not worth the trouble right now. So yeah, that's it for this video. Thank you for watching. If you have any questions, do leave it in the comment section below, and I'll try my best to answer them. For now, thanks for watching, and I will see you on my next one.